Hey y'all, we are back with the second part of 1.3. In 1.3a, we looked at slope-intercept form. In 1.0, we looked at standard form of a line. Today, we are going to explore point-slope form, which is personally my favorite form of line because it feels like the laziest. We have to do the least amount of work, and it tends to be the most accessible. We use it all of the time in calculus. So, what is point-slope form? So point-slope form has an m, right? So we know that m is slope, just like in slope-intercept form. But instead of having b, the y-intercept, we have this x1, y1, which we've used before when we're calculating slope. So x1, y1 is just any point from the line. It could be the y-intercept, but that'd be kind of silly. Then we'd use slope-intercept form. But it can be any other point. And if we're given 3 points, we can just pick one to be our x1, y1. So when should we use this? Whenever it's easy to find the slope and any point on the line. It could be the x-intercept, it could be the y-intercept, but it could just be any other random point. Okay, so a great place to start is with example 1. I am given a random point that is definitely not the y-intercept, and I have the slope. Okay, so let's label these. That might make it a little bit easier to plug in. So we know that slope is m, and this negative 4, 1, that's going to be my x1, comma, y1. So that's what I'm going to plug in for x1 and y1. And then the regular x and the regular y in the formula just stay an x and a y. Okay, so then using that formula up top, we can go ahead and y minus y1 equals m times x minus a negative x1. And that is all we have to do. If we wanted to change this to slope-intercept form, we could solve for the y, distribute the 2/5, and then add 1 to both sides. But we don't have to. That's what I meant when I said that this feels like the lazy form of a line. We just plug in that point, and we are done. We are good to go. There is one challenge with this, and we'll address that in just a second. Okay, so let's look at B. We have a line that passes through a point. That's going to be my x1, y1, and a slope of negative 3. Oh, there we go. Okay, so I can go ahead and plug that into my equation of line. Y minus negative y1 equals m times x minus x1. Done. Okay, and I mentioned a challenge. A challenge that comes with this is, on your graphing calculator, you only have the button y equals, right? So on your GDC, or graphic display calculator, right, you just have a y button. Or I'm sorry, y equals button. Because we have to do like y1 equals, y2 equals, and the y is not all by itself here. Okay, but let's work smarter and not harder. We could distribute the 2/5, right? We would have to do that to rewrite it in slope-intercept form, but I don't need to rewrite it in slope-intercept form. All I have to do is just add 1 to both sides, and I'm just going to leave it outside the parentheses. Plus 1 on the outside here. And then I am all done. I can type this into the calculator just fine, right? Because I have y equals, and then this is the part that I would type in. So that's a nice little trick. We could also, I know it doesn't ask us to, but we could also do that on B over here, where I could just subtract 1 from both sides real quick and get y equals negative 3 times x minus 7 minus 1, and graph that in the calculator. Okay, so in example 2, we are also going to write this in point-slope form. but we need to use the slope formula in order to find out the slope, right? I'm just given 2 points. So notice we're also supposed to write 2 equations because we can choose either point. Okay, so let's go ahead and start by finding the slope. Slope equals y2 minus y1. If you need to label your points, that's not a bad idea. Okay, and then we get to choose. We get to choose either of these points. So if I use the point 3, 2, then my equation is going to be y minus y1 equals m times x minus x1. Okay, and it says to check it by graphing it in my graphing calculator. So let's go ahead and add the 2 to both sides. And I get this equation, y equals 3 times x minus 3 plus 2. Okay, but what if you had chosen the other point? How are you supposed to know which point to choose? And the answer is, it doesn't matter. And I'm going to prove that it doesn't matter. And we can prove it 2 ways. Y minus y1 equals m, same slope, x minus x1. Okay, we need to graph it in our calculator. And if you graph both of these in your calculator, you're going to end up with 2 lines that are right on top of each other. They're actually the same exact line. And that's how we know that even though it looks a little bit different, they actually are the same exact graph. Another way that you could prove that is by distributing the slope to rewrite these both in slope-intercept form, and they'll have the same y-intercept. Because let's look at graphing this. So I'm just going to graph it using these 2 points, 3, 2, so 3, 2, and 5, 8. And we can go ahead and graph that line. It's not perfectly straight. But if we used a ruler, we'd be able to get that a little bit straighter, and they would have the same y-intercept there. Okay, so let's go ahead and do the same thing on B. So on B, we're actually given the x-intercept and the y-intercept. So we could write this in slope-intercept form if we wanted to, but we're going to need the slope regardless. Minus -5. And it does ask for 2 different equations using point slope form, so I'm going to go ahead and do that, even though I could use slope intercept form here. M times x minus -5. Okay, there's one equation of a line. Let's go ahead and use my y-intercept. Oops. Y minus y1 equals m times x minus x1. And x minus 0 we don't really have to write. I am going to go ahead so I can graph this in the calculator, move the 7 over. And now we can see that it is actually in slope-intercept form, right? Because that x minus 0 is the same thing as just x. And I would get this exact equation if I distributed the slope to both of the terms boop, in this equation. So again, same line, which I can graph by graphing my 2 points and doing the best I can to connect them with a straight line there. Alrighty, so that's point slope form. Let's do some more examples. Example 3, using either formula, write the equation of the line, write your final answer in slope-intercept form. So we're going to get some practice changing from point-slope form to point-intercept form, or slope-intercept form now. Okay, I have the slope and a random point, so I'm definitely going to start with point slope, y minus negative 4 equals m times x minus x1. Okay, I'm going to go ahead and distribute this negative 3. Subtract 4 from both sides. And my final answer is in slope-intercept form. Okay, on B, we need to be careful. This is my x-intercept. So I'm definitely going to choose point-slope form, but first we have to calculate the slope of our line. And then we can choose either point. This seems like an easier point to plug in, so I'm going to choose that one. You don't have to, though. You could use 5, 5 if you wanted to. But since I had one of them as 0, that's just going to go away, and we can distribute this 5/4. Beautiful. And C, yay, we have the y-intercept, which means we can just go straight to y-intercept form. Y equals m x plus b. And instead of plus negative 3, I'm just going to write minus 3. Nice and easy for that one. All right, so 2 SAT, ACT practices. An Uber ride from the school to the beach is $4 plus $1.75 per mile. Okay, so per mile is my clue that we're going to do $4 plus $1.75 times m, where m is going to be the number of miles that I drive per mile. Write an equation. Oh, how lucky is that? I already have my equation just by reading it and jotting down some notes. Write an equation to represent the cost. My total cost, C, equals $4 plus $1.75 per mile driven. Ah, that was so handy. Okay, if Miss Spillers only has $10 and needs to get to Casino Beach, 2.8 miles away, will she make it? Okay, so 2.8 is talking about the miles, so I'm going to plug that in for m in my equation. So we end up with my total cost is 4 plus $1.75 per mile. Okay, and you may notice that I haven't done anything with this $10 yet. It's not there to trick me, but I don't really need that to calculate the mileage here. Okay, so I'm going to do $4 plus $1.75 times 2.8, and we get that my total cost is $8 and, well, in my calculator I just get 8.9, but we know that that's going to be $8.90. So now I'm going to go back and think about that $10. She has $10. Is that enough? And the answer is yes. Yes, she will make it. She has $1.10 left over. Okay, Kevin has a collection of quarters and nickels. Not much I can do with just that statement, so we've got to keep reading. Write an equation to represent the total value. Okay, so total value is, I'm going to use V for value, equals. Okay, X is the number of quarters. So if I'm talking about the value, quarters are worth 25 cents. So if X is the number, I'm going to have 0.25 times X. And I'm going to add that to the number of nickels, Y. So nickels are worth 5 cents each. Okay, and now I have my equation for the value. What do I need to do with that? If the total value is $5.50, okay, so this is V. Kevin has 17 quarters. Was quarters X or Y? Let's check. Quarters was X. So X is 17. How many nickels? Okay, well, I have my equation. Let's go ahead and I have some variables defined here. So 550 for V equals 0.25. We said that X was 17. Alrighty, so then we need to go ahead and figure out how much is 17 quarters worth. So 4.25 so if I subtract 4.25 from both sides, we have $1.25 in nickels. The question is, how many nickels is that? Which, it's a good thing I have some algebra. Looks like that is 25 nickels. And there we have it. That is the wrap up of 1.3, and I will see y'all